Let's have a look at question 3 now. So suppose that the marginal cost is 2 and that we have a Cournot competition. So we have a second identical firm in this market. Now how much will each firm produce in equilibrium? So what's changing now? It's changing that the quantity served in the market is going to be from two companies. So this is the quantity total in the market because this is the demand of the entire market. Now, since we have two companies that produce output, the price function would look like 8 minus quantity of the first company plus quantity of the second company. And if we open the brackets here, it will be 8 minus Q1 and minus Q2. Now, what's the intuition of this Cournot competition? What does it mean? This is an example of static game theory. Static game theory. Now, what's the intuition here? The idea is that there are two players in the market and they both know that they each are going to produce to maximize their own profits. So the first company takes into account in his own profit, when he wants to calculate his own profit, he decides for his own quantity to produce, that's going to be a function of the quantity that the other guy is willing to produce. So he's taking into account the fact that there is a second quantity in the market, a second producer in the market. Now the same logic, the same analogy happens for the producer of the second company. For him to find out his equilibrium, he's also going to calculate his quantity that maximizes profit, and that's going to take into account also the fact that there is this guy from the first company that's going to produce. So they're both taking each other into account at the same time. That's why it's static. So we solve this as a system of equations simultaneously at the same time. Hope this makes sense. Now let's see how that works out with some math over here below. Let's do it for first company and then for the second company. So for the first company, what we have is this. For the first company, what we have is the following, that the profit for the first company is going to be the difference between the total revenue of the first company minus the total cost of the first company. So how's that going to look? We're going to have profit for the first company equals to the price times the quantity of the first company that produces, minus the total cost is going to be the marginal cost of 2, so 2 euros per every quantity of production, quantity that the first company produces. There's nothing told about fixed costs, so we don't incur any fixed costs. Now let's expand this equation by substituting the price function. So we will have profit of the first company is equal to the price function of 8 minus Q1 minus Q2 multiplied with the quantity of the first company minus 2 times Q1. Now if we open the brackets, what do we have? 8 times Q1, so we have 8 times Q1 minus Q1 times Q1, so that's Q1 to the power of 2, minus Q2 times Q1, so minus Q2 times Q1, and then we just subtract the cost, minus 2 times Q1. Okay, if we write it a bit simpler, to make it a bit more neat, the profit in the first company is going to be equal to 8Q1 minus 2Q1, that's equal to 6Q1 minus Q1 square minus Q2 times Q1, Q2 times Q1. Now what we can see is that profit is a quadratic equation depending on the quantity of the first company. So we have a quadratic function over here that's going to look concave. So if we draw it real quick to see the relationship between profit and the quantity, it's going to look something like that. Profit of the first company, quantity of the first company. It's going to be a parabola with a concave shape, meaning it's going to increase and later on start decreasing. So we're interested in the peak of the graph. We're interested to find out the quantity that is going to maximize the profit for the first company. And the reason we're going to have a peak of the graph and then the profit it starts falling is because beyond a certain point, when the production increases a lot, so once quantity increases in the market, the price is going to fall and respectively the total revenue are going to start falling. So that's why the profit starts falling beyond a specific point. That's the logic here. Now, to find out this level, the quantity that maximizes profit, we can see that we have a slope that is flat, and that means that the derivative is going to be equal to 0. So what we're looking for is for the derivative of the profit of the first company, derivative with respect to Q1. So we're going to differentiate this equation, 6Q1 minus Q1 squared minus Q2 Q1 with respect to Q1. So let's do it over here. 6Q1 derivative with respect to Q1, that's equal to 6 minus Q1 squared, derivative with respect to Q1, that's 2 Q1, and then minus Q2 times Q1, derivative with respect to Q1, that's going to be equal to Q2. And the derivative, we said, has to be equal to 0 because the slope is flat at that point. That's equal to 0. Now what we're interested in is to find out the optimal quantity of the first company. So the quantity of the first company that's going to maximize his profit, since we want to find that, let's take it to the other side. So we will have 2 times the quantity of the first company is equal to 6 minus Q2. And now if we divide both sides by 2, we will have that the quantity of the first company is going to equal to 6 minus Q2 divided by 2. And that's equal to 3 minus a half Q2. 3 minus a half Q2. So we found the relationship that we were speaking about. The quantity of the first company depends on the quantity of the second company. And that's what we said in our intuition in the beginning, that to maximize profit, we'll find the function of the quantity of the first company depending on the quantity of the second company. Now, let's leave it like that for this video. In the next one, we're going to do the relationship for the second company, and we'll see what the quantities are going to be.